Have you ever looked up at a giant airplane in the sky and wondered, how does it stay up there? How does it manage to float so effortlessly, almost as if it were weightless? It seems impossible that something so heavy can defy gravity. Yet, every day, thousands of these massive machines take to the skies. The answer lies in a fascinating force called lift. Lift is one of the four fundamental forces of flight, alongside weight, thrust, and drag. Lift is the upward force that counteracts an airplane's weight, allowing it to soar through the air. Without lift, flight would be impossible. Imagine holding your hand out of a car window as you drive. The faster you go, the more force you feel against your hand. If you tilt your hand slightly, you can feel the air pushing it upward. This simple experiment demonstrates the basic principle of lift. This is similar to how lift works for airplanes. The wings of an airplane are specially designed to generate lift. The wings of an airplane are specially designed to generate lift. They are not just flat surfaces, they have a unique shape. As the plane moves forward, air flows over and under its wings. This movement is crucial for creating lift. The shape of the wings, called an airfoil, is crucial. The airfoil is designed to make the air travel faster over the top of the wing. This unique shape makes the air traveling over the top of the wing travel faster than the air flowing underneath. This creates a pressure difference. This difference in airspeed is what generates lift. The higher pressure under the wing pushes it up, while the lower pressure on top allows it to rise. The airfoil shape of an airplane wing is a key to understanding flight. It's not just a flat surface, it's carefully curved on the top and relatively flat on the bottom. This specific shape is designed to manipulate the airflow in a way that creates lift. As the airplane moves through the air, the shape of the airfoil forces the air flowing over the top to travel a longer distance in the same amount of time. This means the air on top is moving faster. According to a principle called Bernoulli's principle, faster moving air creates lower pressure. Meanwhile, the air flowing under the wing encounters a flatter surface, so it doesn't speed up as much. This slower moving air creates higher pressure. The difference in air pressure between the top and bottom of the wing generates lift, pushing the airplane upward. While lift gets an airplane off the ground, it's thrust that propels it forward. Without thrust, an airplane would simply glide back down to the earth, unable to maintain its altitude or speed. Thrust is essential for sustained flight, allowing the aircraft to travel long distances and reach its destination efficiently. Thrust is the force that overcomes drag, the resistance the airplane encounters from the air. Drag acts against the forward motion of the airplane, trying to slow it down. Without sufficient thrust, drag would eventually bring the airplane to a halt. Think of it like this. If lift is the force that fights gravity, thrust is the force that fights drag. Both forces must work in harmony to keep the airplane in the sky and moving forward. The balance between these forces is crucial for stable and controlled flight. Thrust is generated by the airplane's engines. These engines come in various types, each designed to produce the necessary force to propel the aircraft. The efficiency and power of these engines are vital for the performance of the airplane. In a propeller-driven airplane, the engine rotates the propeller, which acts like a giant fan, pushing air backward and propelling the plane forward. This method of generating thrust is highly effective for smaller aircraft and those designed for shorter distances. Jet engines, on the other hand, burn fuel to create a powerful blast of hot gas that is expelled out the back, creating thrust. This type of engine is used in larger, faster aircraft, capable of traveling at high speeds and covering long distances. The amount of thrust an engine generates determines how fast the airplane can fly. More thrust means higher speeds, allowing the airplane to reach its destination quicker and more efficiently. The faster the air flows over the wings, the more lift is created. This relationship between speed and lift is fundamental to the principles of flight. This is why airplanes need to accelerate down a runway before they can take off. They need to generate enough thrust to create enough lift to overcome gravity. The runway provides the necessary distance for the airplane to build up speed, ensuring a safe and successful takeoff. As an airplane moves through the air, it encounters resistance. This resistance is called drag, and it acts in the opposite direction to the airplane's motion. Drag is caused by the friction between the airplane's surface and the air molecules. Think about walking through a swimming pool. The water creates resistance, making it harder to move forward. Air, although less dense than water, also creates resistance for a moving airplane. The shape and size of an airplane, as well as its speed, all affect the amount of drag it experiences. Streamlined designs with smooth surfaces help to reduce drag. Engineers spend a lot of time designing airplanes to minimize drag, making them more fuel efficient. Section 5. Earth's pull. Gravity's role in flight. We can't talk about flight without mentioning gravity. Gravity is the force that pulls everything towards the center of the Earth, including airplanes. It's the force that lift constantly needs to overcome to keep an airplane in the air. While gravity wants to pull the airplane down, the lift generated by the wings opposes that pull. As long as the lift force is equal to or greater than the force of gravity, the airplane will stay airborne. Pilots can control the amount of lift generated by adjusting the angle of the airplane's wings. This angle is called the angle of attack. A higher angle of attack generates more lift, but it also increases drag. Section 6. Taking control. How pilots steer. Pilots use a variety of control surfaces on the wings and tail of the airplane to maneuver it in the air. These control surfaces are essential for the safe and efficient operation of the aircraft, allowing pilots to make precise adjustments during flight. These control surfaces work by changing the airflow over different parts of the airplane, which in turn alters the lift and drag forces. By manipulating these forces, pilots can control the aircraft's orientation and direction. Ailerons. Located on the trailing edge of the wings, ailerons control the roll of the airplane. They are crucial for maintaining balance and stability, especially during turns. Moving one aileron up and the other down creates a difference in lift between the wings, causing the airplane to bank. This banking motion is what allows the airplane to make smooth and controlled turns. Rudder. The rudder is located on the vertical stabilizer or tail fin. It plays a vital role in controlling the yaw of the airplane. It controls the yaw, which is the side-to-side movement of the airplane's nose. Proper yaw control is essential for coordinated flight and helps in aligning the aircraft with the runway during landing. Moving the rudder changes the direction the airplane is pointing. Pilots use the rudder in combination with other controls to execute precise maneuvers and maintain the desired flight path. Elevator. Situated on the horizontal stabilizer, the elevator controls the pitch of the airplane, which is the up and down movement of the nose. This control surface is essential for managing the aircraft's altitude. Moving the elevator up causes the airplane to climb, while moving it down causes it to descend. By adjusting the pitch, pilots can control the rate of ascent or descent, ensuring a smooth and safe flight experience. Section 7. Mastering the skies pilot controls explained. Pilots use a combination of controls in the cockpit to manage the airplane's flight. These controls allow them to adjust the engine power, control surfaces, and other systems to maneuver the airplane safely and efficiently. Control, yoke, stick. The control yoke or stick is the primary control for rolling and pitching the airplane. Moving the yoke left or right controls the ailerons, while pulling back or pushing forward controls the elevator. Throttle. The throttle controls the engine power. Pushing the throttle forward increases engine power, which in turn increases thrust and speed. Pulling the throttle back reduces engine power. Rudder pedals. The rudder pedals control the rudder. Pushing on the left pedal moves the rudder to the left, while pushing on the right pedal moves it to the right. This allows the pilot to control the yaw of the airplane. Section 8. The dance of forces, how planes stay airborne. An airplane in flight is a delicate balance of four forces: lift, thrust, drag, and gravity. These forces are constantly interacting, and it's the pilot's job to manage them to maintain a stable and controlled flight. Lift versus gravity. Lift counteracts the downward pull of gravity, keeping the airplane aloft. Thrust versus drag. Thrust overcomes the resistance of drag, propelling the airplane forward. When these forces are in equilibrium, the airplane maintains a steady altitude and speed. To climb, the pilot increases lift or thrust. To descend, lift or thrust is decreased. Turning involves banking the airplane using the ailerons and rudder while adjusting thrust and elevator as needed. Section 9. Conclusion: the marvel of modern aviation. The ability of airplanes to defy gravity and soar through the sky is a testament to the power of human ingenuity. By understanding the principles of lift, thrust, drag and gravity, and by harnessing these forces through clever engineering and skilled piloting, we have conquered the skies and opened up a world of possibilities. From the earliest gliders to the sophisticated jetliners of today, the science of flight continues to fascinate and inspire. Next time you see an airplane overhead, take a moment to appreciate the intricate interplay of forces that make it all possible.